I'm now going to give an example of what the data file should look like, and this same example is used in all subsequent videos to demonstrate how to use RCTS. So consider a hypothetical RCT. These data are all made up. The intervention is an after-school program with an academic focus. Assume 39 middle schools are randomized to a treatment or control group in 10 school districts. The treatment group is offered access to the after-school program, whereas the control group is not. This is a cluster design because schools are randomized, and is a block design because random assignment is conducted separately in 10 school districts. The sample contains 2,256 fifth graders. Now this is a relatively complex and large RCT, but the data format for this example is very similar to the format for less complex RCTs. The key research questions are: 1. Did the after-school program improve student math and reading test scores? And 2. Did impacts differ by gender, by math and reading proficiency level in the prior year? We assume that student-level data are obtained from school records, that the outcomes are math and reading test scores in the following spring after random assignment, that the baseline subgroups are gender, math and reading proficiency level in the prior year, and that the baseline covariates are gender and test scores in the prior year. Below is a description of variables in the RCT data file. The variable district is the block ID that is coded from 1 to 10 and is masked. The variable school is the cluster ID that's coded from 1 to 39 and is also masked. The variable treatment is the treatment control indicator variable that is coded as 1 for those in treatment schools and 0 for those in control schools. The two variables in purple, math score and read score, are the outcome measures for the study. The variable gender, which is used for both the subgroup analysis as well as the covariate, is coded as 1 for girls and 0 for boys. The subgroup variable math proficiency in the prior year is coded as 1 as not proficient, 2 as proficient, and 3 as highly proficient, and similarly for the reading proficiency subgroup. The variables in green, prior math score and prior read score, represent the covariates that are used for the analysis. This table shows selected variables in the student-level data file. There's one record for each student in the sample. Selected records are shown for students in District 1 and in Schools 1 and 2. School 1 is a control school because the variable treatment equals 0, and School 2 is a treatment school because the variable treatment equals 1. We show selected data values for the math score outcome, the gender variable, and the prior math score covariate. The letter E represents missing data. As I mentioned earlier, for cluster designs, the data file can either include individual level records or it can include cluster level averages. The table in this slide shows the cluster level data format for our example. There are 3 panels of school level averages. The first panel pertains to the full sample analysis. The second panel in green pertains to the subgroup analysis for girls. And the third panel in gray pertains to the subgroup analysis for boys. The variable math score is now the average math score of students in each school for the full sample, girls or boys. The variable full underscore SUBG, which is required, should equal 1 for the full sample analysis and 0 for any subgroup analysis. You can see that the gender variable is set to missing for the full sample analysis. Finally, you can see in the final row of the table that math score is missing, which could mean that there are 0 boys in School 3, or all the boys have missing data. The user's manual has more details on this data format.